Hey everyone, let's solve the today's LeetCode challenge, which is LeetCode 1838, frequency of the most frequent element. So here in this problem, we will be given an array. Along with that, we are given a value k, which is the operation we can perform on that array. And what is that operation? The operation is like nums of I plus 1. We can increment a value of any item in this array by 1. And by performing add max k operations, we need to return the maximum frequent element in this array. Let's try to have a look on an example. Let's look at an example. So in this problem, let's say for the given example 1, 2, 4, and the value of k is 5. Here we have to return any element which can be the maximum number of times after performing add max k operation. We don't need to perform all the operation. We can have one operation, two operation like this. So how do we do that? Like that frequent element will definitely be from this array. So why don't we just choose for all the elements and check like what is the maximum frequency we can get for that element. Let's say start with 1. For the element 1, what can be the maximum frequency? Maximum frequency is the one is already here. And can we convert any other item using this operation? No, we can only increment the value by 1. We are not allowed to decrease anything. So 1 is having frequency 1 with k 5 as remaining. K is 5. Let's try for 2. For 2, 2 is already present here. And then can we convert any other element to 2? Yeah, we can convert 1 to 2 by using one operation. So can we other any other element apart from 1? No. So 2 is going to have a maximum frequency of 2 with the remaining k value of 4. So let's try with 4. 4 is already present, so 1. Can we convert? So who you should convert first, 1 or 2? We are going to convert 2 first because this item is very close to 4. So firstly, like for any item, for any numbers of I, we have to get the maximum element which is just smaller than that value, and we will increment that value by using our remaining operations. So here in this case, let's try for 2. Can we convert 2 to 4? Yeah, using 2 operation. So I also added 1 in the frequency of 4 from 2 using k equal to, earlier k was 5, now k will remaining 3. Now can we convert 1 to 4? Yeah, if we have to convert 1 to 4, we need 3 operations. Do we have 3 operations remaining? Yeah, right. And we can add 1 to this. So 4 is going to have frequency 3. We are going to return maximum frequency, so which is 3. 3 is our answer. Okay. So like how do we approach that? So firstly for every element, if we are going to check for every element, we need the maximum element which is less than that. So it means at least we have to sort the array. And once we have sorted the array, what we will do now? We will keep tracking the window from the starting or maybe from the end, whatever you feel like. And for every window, we will see whether the window can be converted to the maximum element or not. Let's say for element 1, 2, 4. First window can be of one element. This window is of two element. And this window is of three element. We will on every window we will see whether we can convert that window to four or not. First window is converted to one. Second window we will see whether we can convert it to two. third window, the maximum element is 4. So we will try to convert this whole window to 4. If it is possible, then it is fine. If it is not possible, it means like how it will be possible. We have enough value of k. If we don't have enough value of k to convert this whole window to maximum element, in that case we will reduce from the starting like this. So we will go through each window and track the maximum window size. That would be our answer. So how do we know that whether we can convert this window using our operation? So let's say the window's actual sum is total. Okay. And the actual sum is, let's say we are taking a window of 1 or 2. Actual sum is total, which is 3, plus the number of operation we can perform. Here in this case it was 5. So we are allowed to have 5 operation. 5 operation. This value should be greater than equal to the value we are going to get from this window. So what do we expect from this window? To have same number of element in this window. So which will be the maximum element, which can be our current element. So nums of I into length, window length. So nums of I, let's say from 1 to 4, if we are at I equal to 1. So nums of I equal to 2, and the window length should be, currently we are starting from 0. So window length is 2, which is 4. So if we are able to achieve 4 using our given operation count, how do we do that? Like the actual total is 3 here, plus we are allowed to have k operation. So by using these operation, can we achieve 4? We can, k is actual 5, which is 5 plus 3 is equal to 8, which is more than that. So yeah, this window is achievable. We will go through all the windows and we'll see the maximum window size. These were the two important aspects. Firstly, we have to sort the array, that is going to take n log n time, and then we are performing the sliding window, which is going to take linear time. So the time complexity would be capital of n log n. Okay, let's try to write the code for this problem.
Here we will start by sorting the given arrays dot sort nums. Now we will use the sliding window over this array. Let's take left as 0. I'm taking answer as a variable to store the maximum sliding window length so far. Currently it is 0, as well as I also need to track the current sum. Okay, now for the right pointer, going from 0 to nums dot length, right, plus plus. Here firstly I will just increment the current sum plus equal to nums dot, right. Now, like, what was our condition to check whether it is a valid sliding window or not? The length of the window into current element. The length of the window current element, it is going to be compared with the actual sum of that window plus number of operation. If the, let's say, if the actual sum and the number of available operation can make it to this window, it means we are going to consider this window. So if it was less than equal to this, it is a valid window. If it is greater than this, it is not a valid window. In that case, we just have to reduce the window size, or maybe increment the length. So what is the length of the window? Right minus left plus 1, because we are considering right and left both. While our window is not valid, what we will do is we will increment the left plus plus, and also the element we added in the sum, which is the left element. We are also going to reduce that from our sum minus equal to nums dot left. Okay, and after that we can just capture the answer length, math dot max answer, and the sliding window length, which is right minus left plus 1. Okay, now we have captured all the sliding window lengths. We can return the maximum one, which is in our answer. Let's try to run the code. Okay, it is failing for this case. In this case, like our constraints are very high, so we need to take that sum as a long variable, it's not fitting in the int. Now it is passed. So what we did is we just sorted the array and checked for all the sliding window whether that sliding window can be of the same number of elements. If that is possible with the given operations, we will just capture the window length. Trying to submit this problem. Okay, it is submitted successfully. Thank you guys.